I want to take you to what I think is the simplest schema anyway that I can come up with that can represent the absolute most stuff and can represent pretty much anything that we've talked about in this course. And as you might imagine, because it can do that, it has to be pretty open-ended. It has to be pretty subtle and sophisticated. Subtle and sophisticated in schema terms mean a couple of practical things. Practical thing number one that it means is that it's going to be kind of hard to understand. Practical thing number two that it means is it's going to be pretty hard to create an instance that obeys it or that creates it. And so you should expect to either let this topic go by and say, well, you know, whatever, or look at it pretty closely and have to kind of puzzle through some of these things in order to really get a feeling for it. What I want you to get out of this, and the exercise that accompanies this topic, is the idea that we can have a very open-ended, a very loosely quantified schema that allows you to do a lot of things, and we can unite all of the access structures and all of the different things that all of the different items and information types and access structures and all of that under a very small, simple schema. And that's why I call this the model to rule them all and in the schema bind them, with obvious implications. So let's take a look at this schema, and let me describe briefly how it works. You'll get a chance to work with it in the exercise that accompanies this topic. So it's called the one, or thesaurus one. You can read that as well. And it's a set of terms. Okay, so we're no different. But now these terms can be the words in a paragraph. These terms can be really anything you want them to be. They can be at whatever level. And we're going to be able to relate them to other terms. So a term has an ID, of course. They always have IDs. If we wanted to be even simpler about it, we could say that the term name itself is the ID, but I didn't want to go that far. Okay, and then every term has a relationship. The relationship has a referent, and the relationship has a type ref ID. Okay, let's unpack those things. So it has a referent. The relationship's referent, if you're remembering from our terminology for associations, each association has a reference and a referent. The referent is the thing that's pointed to. And I'm not sure why this referent doesn't have the ID ref data type attached to it. It needs to, so I'll fix that. And this referent is actually another, this referent is another term. So every term points to other terms. So if you remember from our discussions about thesauri, this is kind of where we came to with the thesaurus. We said that the thesaurus has a set of relationships, and we're really going to create the types for those relationships. And in the thesaurus, we said it could be an enumerated list of types, synonym, antonym, broader term, etc. And it's going to be a relationship to another item. Another term. Same thing's going on here. We have a term with relationships to other terms, and that referent is another term. And as I said, I apologize, that should be the ID ref data type, because that referent points to the ID of another term. Now, down to this type ref ID. In the earlier example, and if I wanted to make this simpler, I would say, well, that's an enumerated list. I enumerate all the different kinds of relationships that I can have. But I don't want to be that closed. An enumerated list is a closed list, right? It's a finite list of kinds of relationships between items. But what if I want you to be able to model not only the fact that there's a relationship, but I want you to be able to model what kinds of relationships, and I want you to be able to create whatever number of sophisticated kinds of relationships you want. I also want you to be able to create relationships of relationships. So you can have family as a relationship, and then clan is a relationship that comprises all of those families. All the families put together is a clan. And then a nation might be a set of clans that are all put together. Those are all relationships. You can have family-to-family relationships. You can have relationships parent to child. You can have clan relationships, which are all the families grouped together. You can have nation relationships, which are all the clans grouped together, right? So those are more than I could possibly think to model inside of an enumerated list. I'd have to have a very, 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 very large enumerated list. And I don't want to have a large enumerated list. I want to simply give you the ability to create whatever relationships you want. So how do I do that? The relationship, the type ref ID, that's the type of relationship, is itself a link. It's a link to another term. So not only are my terms themselves terms, but my relationships are also terms. In fact, all there is terms. Now, term all of a sudden becomes a bad word because, an improper word, because it's not terms that I'm talking about now. It's entities or, primary things or something. In another exercise, I'll call them things because we really don't even know what they are because they could be anything. So let's keep the word term because I don't want this to get so abstract that you completely lose track of it.